Hello, everyone. Welcome. My name is Michael McNally. I'm about to introduce our guest speaker. David Milne is connected to Google through Ian Witten, who is the professor who is David's advisor. He was also the PhD advisor for Craig Neville Manning, and so that's the connection by which he was introduced to us. And he'll be presenting some of the research results and ideas from the paper that he just presented in Napa Valley at the CIKM conference, the Conference for Information and Knowledge Management. And this just won the best paper of the conference. So congratulations to David Milne for that. If you'd come up and welcome to Google.
Thank you. Is this working? Cool. Thanks for the name dropping. Okay, so I'm here to talk about knowledge-based information retrieval with Wikipedia. I don't mean going to Wikipedia and finding the information you need. That's not all that interesting. What I'm talking about is using Wikipedia as an intermediary between queries and documents and trying to have a search engine or a digital library consult that to try and help things along. Also, my abstracts might have been a little bit misleading. I'm not going to be talking just about Wikipedia and how good it is and how bad it is. I'll be more talking about the specific things I've been working on with it. So I've been creating a system called Coro and working on some related problems such as semantic relatedness and Wiccafication. These are going to be pretty cryptic at the moment, but as I go through the talk, I'll talk about them more, and I'll actually demonstrate a live system for each of these problems. Okay, but first I need to motivate my talk, and this is the bit where I need to criticize Google, criticize search engines. Not the best venue to try and do this. But we all know search is not solved. There's improvements we can make. And the main limitation that I'm interested in here is that current search engines don't understand us, really. They deal in characters and word patterns. They don't deal in people or places or events or concepts. So yes, we do lots of really cool stuff with link analysis or statistical analysis of what words fit with what other words, or click-through behavior. But really, fundamentally, queries and the web pages, we're looking over them with, may as well look like this, right? They may as well just be plain characters. What I'm going to be talking about is an idea of how can we move from these just characters and patterns of characters to actual concepts and ideas and people. The idea is called knowledge-based information retrieval, where we just have some kind of external ontology or knowledge base or thesaurus that we consult whenever we encounter a document or encounter a query to try and find out a bit more about what it means. It's definitely not a new idea. It's been around for a long time. And it's not one that's really worked out so far, I have to admit. There's been lots of research on it, but yet, as I said before, the things people use, the search engines that people use, don't really work with this. Correct me if I'm wrong, because I don't know exactly what goes on inside Google. But the things I keep hearing about have nothing to do with consulting knowledge bases and actually finding out what these things mean. And there's a pretty obvious reason why this hasn't worked so far, and that is we've never had the right knowledge base. So you think of what we would need to support this on a web scale, Google scale. We'd need something that knows about everything and can connect everything together and knows about all the different ways that we're talking about these things. And simply, computers aren't accurate enough. We don't have the NLP sort of technology to gather this automatically, and humans aren't quick enough to deal with all the information that could possibly be coming in. Except that last bit might have just changed. With the advent of Web 2.0, we can now throw millions of people at the problem, and it's actually quite possible that not only could they make this knowledge base, but it's quite possible that they already have. Of course, from the talk, the title of the talk, I'm obviously talking about Wikipedia. So let's think of specifically how it could be considered a knowledge base. I'll talk about this quickly. What we need from a knowledge base fundamentally is a thing that tells us what topics and concepts are out there, how those topics are referred to, like how can we connect them up from the documents and from the queries, and also how do those topics relate to each other. So how can we usefully navigate from a topic to another topic, or identify useful relations between topics. Wikipedia covers all these bases. So as an example, I'm going to talk about rugby because I'm a New Zealander, which fundamentally means I'm fanatical about this sport. Does anybody else know what this sport is? It's basically, it's gridiron without the padding and without the rules, pretty much. So last time I checked, I did a crawl on Wikipedia like a year ago to find out how many articles there are about rugby. And it's like several thousand of them for this obscure sport, which at least is not very interesting to Americans. So overall, in all of Wikipedia, there's more than 2 million articles and categories describing different concepts that are out there. And they cover things like the sport itself, different events that are going around on the sport, different teams, all the way down to individual players and tactics and referees and things like that. How those topics are referred to. Wikipedia maintains a network of redirects which connect alternative titles or synonyms to the concepts. And also, there'll be lots of links going on from one piece of text that might mention sort of ABs or the New Zealand rugby team, things like that, to this article. So we can tell from those sort of things how people are referring to these concepts. And also how those topics relate to each other. Well, we've got all this massive network of links between these concepts. So here, the All Blacks is linking to New Zealand and rugby union and other teams like the Wallabies. So we can draw a network between these concepts. And also, we can get a bit more structured information from things like the categories. There's a big hierarchical structure which organizes Wikipedia. You know, tell more logical things like rugby union is a type of rugby, which is, again, in turn, a type of sport. And there's a huge network. I have to be careful saying huge at a Google crowd, but there's a very large network of connections between these concepts. So if we take a knowledge base from Wikipedia in this sort of way of mining the concepts and all the relations between them, we get a very, very large one. So here's a comparison of other things that people have used in academia. There's WordNet, which weighs in at about 120,000 concepts. ResearchPsych weighs in at about 300,000 concepts. And here's Wikipedia drawn to scale. Right. Not only that, but it's got far more potential for growth in the future. So ResearchPsych has been getting developed over the last 20 years or more, whereas Wikipedia has only developed in the last 7 years, and it's accelerating. I have to point this out because I'm a cheap student, but who knows how much ResearchPsych cost to produce. You know, employing professional ontologists and philosophers for 20 years is not cheap. Whereas Wikipedia was negligible cost. Also, Psych exists in one language, whereas Wikipedia, with some caveats, you know, there's very big differences between the amount of information that's contained within different languages, but it exists in 250 languages. Anybody who's involved in research Psych would be crying foul now because there's a very big difference between Wikipedia and Psych fundamentally. Psych and other ontologies are very formally defined, carefully defined. They're designed so that you can do inference. We can tell things like George Bush is a head of state, or he's the president of the United States. The United States is a democracy, therefore President Bush must have been voted in at some point. We can do things like that with the formal structure. But with Wikipedia, in comparison, it's a complete mess, right? Anybody can connect two different topics up in any way they want. They can refer to these topics in any way they want, sometimes not particularly complementary, you can see there. So a lot of researchers have seen this as a big opportunity. Wikipedia is huge, could have so many potential applications, but we need to tidy it up and turn it into an ontology. So there's a lot of research going on that. That's not my field. My field, my hypothesis, is that Wikipedia will provide significantly improved retrieval if we allow search engines or digital libraries to consult it as it is without making it tidy. We don't need to make it tidy. It's not a question of sophisticated NLP or AI, artificial intelligence. It's more a question of HCI. My reason for this intuition is that people are using Wikipedia to find information all the time. And the way all of its relations developed was through people thinking this link is going to be useful to someone else, or this link was useful to me. So if we have a second look at the structure, what would you rather have on hand if you're investigating George Bush? Would you rather have something that dryly labels him as a president of the United States, head of state, person, therefore has two legs, or something like that? Or would you rather have something that can connect them up to any topic that someone thinks, if you're looking at this, you'll also be interested in this, or this, or this? Which would you rather have on hand? Okay. So my methodology is pretty obvious. Let's go make a search engine that uses Wikipedia as it is and find out. The search engine is called Koru. And because I'm just a mere student, the search engine is not web scale. It just works on a finite set of documents. It's designed to be used on digital libraries. So we start with a set of documents, and we cross-reference those documents with Wikipedia to try and find out what sort of topics and concepts are relevant to it. And so we extract basically a thesaurus or an ontology that is relevant to these documents. I call that a wikisaurus. So from this structure, the search engine knows what topics and concepts are relevant to these documents, not just what patterns or characters. And that means anytime someone issues a query which is relevant to these documents, it'll also be relevant to this thesaurus, and therefore we can find out what query topics people are talking about. And so there's a lot of opportunities for improving recall and precision and that sort of thing by doing query expansion. Opportunities to match up these query topics with the document topics in interesting ways. But more interestingly, I think, is that there's opportunities for exploratory search, for making suggestions. You start off with this query, what are the related things that you could be looking at? Okay, this is a little reminder to make me demo the system because I keep forgetting to do that. Okay, so this is a search engine. Let's try the George Bush example. Okay, so on this side, we just have the normal document list that we'd see on any search engine. But on the other side, we see a set of topics that we could be talking about. And so by consulting Wikipedia, we've figured out that this thing is ambiguous. We could be talking about George Bush Jr. or Sr. And we're also talking about controversy. And you can see the sorts of things I'm trying to do with query expansion, like we've added synonyms to the query. Basically, the actual query that was issued over these documents is a big combination of all of these synonyms. And also, we can use this as a starting point for looking at related concepts. Firstly, hang on, just to show that that synonym thing works. We get exactly the same results no matter what we type. And we can also use this as a base for exploratory search for finding out related concepts that we could be looking at. So for example, what has George Bush been saying about abortion? Initially, we don't get any results, but we can easily pick and choose what topics we're interested in. And so we can have a look at actual documents. This is sort of a stay tuned thing. I haven't done much with this yet, but you can also see the documents in the search engine itself. And the idea here is later you'll see how we can pick up topics in the documents and allow people to feed that back into the query. And so because documents are a great place to figure out what you're actually searching for and refine your search. Okay. So I conducted an evaluation on the system where basically I ran it on Trek documents. These are documents for which relevant judgments and different topics that people could be looking over have already been calculated. And from that, I could tell that on this fairly random set of documents that belong to no domain in particular, Wikipedia was able to match the query terminology extremely well. So whenever someone typed a query, 95% of the time, it recognized all of the topics that were in that query and then was able to do something to expand the query. And the recognition and the expansion of topics significantly improved retrieval, statistically significantly, but there would be a lot of work I could do to try and improve that. And so the way it can improve recall, obviously, is we're searching through synonyms, and the way it can improve precision is that it recognizes multi-word topics and can ensure that only the right documents are getting returned. One positive thing we found from like an HCI perspective is that the recognition of topics significantly modified people's query behavior. So we're seeing things like people issuing really long queries. Like this is an example of someone searching for documents about email abuse in the workplace, like spamming and using it too much and things like that, or looking for the wrong stuff. And you can see someone's issued a really long query, which is initially completely useless because it's too specific, but it gives them a base for picking and choosing different permutations, different combinations of what they could be looking at. So people issued a lot of queries, and overall those queries were able to give them better documents in the end. A negative thing we found was that the related topics needed a lot more further investigation. So here's an example of someone searching for the email abuse problem. And here are the related topics I presented for abuse. They're it's not particularly helpful. They're very dire, really. So we need a lot more intelligence of what is actually relevant to the query, what's relevant to the task, what's relevant to the documents behind them. And another thing is the extraction of thesaurus terms was inaccurate. This was basically a prototype system, my first test of the hypothesis. And so there are lots of problems like, say in this example, every time this documents were getting indexed and we encountered the topic security, it always thought it was security, the finance, like security on a loan. And so it didn't know what security, security guards, checkpoints and things like that. It didn't know about that concept. So those are the two main problems: extracting the concepts and disambiguating and finding the relevant concepts, and also finding the relevant relations between these concepts, the useful relations. So that's what I'm going to tackle next. That's what I did tackle next. The first one, looking at how topics relate to each other and how to recommend good topics. I did a lot of experiments in semantic relatedness, and this is the idea of you have two concepts or two terms. How do you measure how strong the relation is between them? So you think of like money and cash, pretty much 100% related because they're the same thing, they're synonyms. Whereas money and bank, that's a bit less related, and money and graduate study is pretty much unrelated. So how can we get a system that can produce those same judgments? This stuff is highly useful for things like AI, data mining, IR. So the advantage of investigating this is I can produce something that will be used by other people. But it's sort of a weird task. It's completely subjective. Like, for example, let's completely ignore the giant carbon footprint I put on the planet getting here from New Zealand and look at the relationship between cars and global warming. You're going to get different responses if you ask the guy who rides a bicycle and the guy who drives a Hummer, right? It's all completely subjective. So what we have instead of ground truth for this task is we have data sets which look like this. They have term pairs, and they just get people to just tell me how much do you think tiger and cat relate to each other. Give me a number. And they average the number over normally 10, 20 people, and we get a value of how much we think these concepts relate to each other. And we want to produce those numbers automatically. Wikipedia is a great way to do this because for this problem we need scale, we need structure, we need to be able to provide measures between lots of different concepts. But we also need structure to be able to do it. We need to be able to identify the actual concepts. We need to tell how much they relate to each other. So as I've said before, Wikipedia covers this pretty well. And naturally that means it's not going to be a new idea if I use this for semantic relatedness. Two other people had tried it before me. There was a system called Wikirelate, which works on Wikipedia's category structure mostly. So a concept is related to another concept if there is some sort of common ancestor in their category structure. And the further up you have to go, basically, the less related it is. And there's another one called explicit semantic analysis, which works on the text in Wikipedia. So you can look at textual overlap. It's a lot more complicated than that. But I could have used either of these two systems, but I decided to try something on my own. And that is, I felt both of these resources were ignoring something important. They were ignoring that massive interconnected structure of hyperlinks that I showed earlier. So I created a system which uses these links to calculate relatedness. So here's an example of how it works. We want to compare bank and globalization. Here's the Wikipedia article on globalization, and you can see it has links to things that are related, like trade, foreign direct investment, human migration. But it will also have links to quite odd things. For some reason, I haven't got an odd example there, but normally there's random links as well. So what we do is we gather all of the links that are coming out of the article globalization, and we can do the same for bank, and we'd get some overlap. And so the overlapping concepts indicate that they're related, but the ones off on either side indicate that they're not related. We can do exactly the same for the links coming into the articles, and we can turn this into a number of how much they relate to each other. Demo. Okay, I'll give some URLs at the end of the talk, but this is my site for the code I'm sharing for working with Wikipedia and mining stuff from it. And it's got some demos, and I'm going to search for how much Google relates to Yahoo. Okay, so we're 75% related, and that's because there's a bunch of things that they have in common, but there's a bunch of things that they don't have in common, right? Exactly. Okay, what do we expect to happen here? Well, it'll still be kind of related because, you know, Microsoft does search, but they do a lot of other stuff as well, so it should be a bit less related. How's that? Is that too much, or? Okay, and then we try another company which, okay, this will still be a little bit related because it's a company, yeah, but 40% related. It's probably a bit too much, I don't know. All right, and let's test something interesting. What's the motto here? Don't be evil. Let's compare Google and evil. What do we expect? How are you guys going? Ooh. That's a bit too much. Okay. The other important thing is that this is working with, you can probably tell, it works with any type of semantic relation. It doesn't matter what type of relation it is. So it works with location as well. I spelled that wrong. Right. And it's also doing disambiguation. So were you aware that Google quite possibly picked the wrong mountain view to set up business in? You could all be hanging out in Hawaii, actually. There's a mountain view in Hawaii. So before we were looking at mountain view in San Francisco, but here we're looking at mountain view in Hawaii. Okay. How well did it work? Well, there are standard data sets like this word similarity 353. I showed the start of that data set. Yes?
Sorry, I want to know how much is the coverage because I just tried Google and Baidu and it says Baidu is not in the list.
Sorry?
I just tried Google and Baidu, but Baidu doesn't seem to have that entry.
Can you try it with case folding? Because it's, you know.
AI.
Yeah?
So you have to think about it.
There's a different search mode. You can do it on case folding. Sorry, I keep saying I'm in HCI, but I make terrible mistakes. This is interesting. It's getting evaluated as I speak. Okay. Oops. Okay, so when I ran it on evaluation data, basically what I found out was quite obvious, really. It works better than doing it on the category structure because we have a lot more information available, and it doesn't work as well as using it on full text of Wikipedia because, again, they have more information available. But the really good thing is, the really good thing is we can do this very, very cheaply. It's only using structured information, and actually all of the structure that it uses, Wikipedia's link structure, can fit in memory. Later on, I'll show you some experiments which are doing this semantic relatedness stuff literally millions of times. So this is important.
So which one is yours?
Sorry, it's this one. Wikipedia link-based measure. Okay. The next problem was, okay, now we can tell when concepts relate to each other pretty accurately. And we can do that with multiple concepts. So we could do things like pick the query, the thing that's related not just to the query, but to all of your query concepts and also to the top relevant documents that are getting returned and things like that. The other problem was being able to identify what topics are being talked about in the documents so that we can index them properly. And this is a task that's been coined as Wiccafication. And the idea is that Wikipedia contains millions of examples of how to connect documents to Wikipedia. Every single Wikipedia article is an article that's been cross-referenced, as in it's got all these links telling you what other Wikipedia articles are relevant. So Wiccafication means basically you take a Wikipedia article and you strip out all the links and you try and put them back in, and you can evaluate it on how well it does this. There's a few problems involved, separate steps. One is which terms relate to concepts and which ones are just prose, separating out stop words, but there's more than just stop words that we need to ignore. Another one is how do we resolve ambiguous terms? Because terms can potentially relate to multiple concepts, like bank could relate to the financial institution, but it could also relate to the side of a river. And another problem is how do we select the concepts that are actually relevant? As we'll see later, we could be picking up everything in the document, but that's not always going to be helpful. So I'll look at the first one, identifying concept terms. And Wikipedia links, if we just gather them up, they would provide a huge vocabulary of which terms can link to which concepts. If anything, actually, this vocabulary is too comprehensive. If we wanted to, we could link to even the stop words in this document, such as the. We have an article about that, or the concept of six or half of something. Luckily, we can easily separate out these sorts of things by looking at how often these terms appear in Wikipedia and how often they're actually used as a link. So a very small percentage of the time, the is actually used as a link, whereas global economy, 15% of the time, when that's encountered, it's used as a link. So that's how we separate out the chaff from the potential concepts. The other problem is resolving ambiguity, like some concepts are ambiguous. Okay, I've created a system which is machine learned. That's because in this sense, in this example, we have millions of training examples of how to identify a correct sense for a concept. Every single link in Wikipedia has been manually disambiguated. It's been manually decided which concept that should link to. And so that provides one good example, obviously, but also all the bad examples, all the things that could potentially have linked to but didn't. So my machine learned approach uses two basic features. The first one is prior probability or commonness, which is trying to identify what are the senses that people actually know about and what are the obscure things that people are not likely to be interested in, because Wikipedia has got a lot of that. So, for example, when people want to add a link to global economy, they could be linking to the global economy, but sometimes this is technically ambiguous in Wikipedia because sometimes they link to the concept of globalization, the phenomenon of governments working together and countries working together. But again, we can look at the prior probability of each of these things being a destination for this term, and we can identify what is the obvious one and what is the less common one. So that's a feature. Obviously, we wouldn't want to rely on this all the time because there are other terms which are more genuinely ambiguous. So as I said before, banks, we could be talking about financial institution, the edge of a river or stream, an underwater hill like a sandbank that people run aground on, or a movement in flight, like you bank a plane. And here are the prior probabilities of each of these senses. And in this case, we'd be fine, but we change the document and we're not. We actually need to pick this one in this case, right? So the other feature is how much it relates to the context surrounding it. What we do is we gather unambiguous concepts from the entire document in which this link is found. And we look at how much our different sense concepts, like each of these sense concepts, relates to each of these context concepts. And I showed you before how we do that. And so we can easily see that the edge of a river or stream relates much more closely to these things, because these are rivers and streams. Okay. I'm sorry, I made a mistake here. That figure is completely wrong. The figure for resolving ambiguity is more like 98% and 97% recall and precision. So sorry about that. Believe me, this stuff is competitive with the state of the art. I can point you to a paper. I can't believe I made that mistake. Okay, the next problem is selecting relevant concepts. So the thing is, Wikipedians do not link to every single article. They make interesting, like quite complex decisions about what to link and what not to link. So in this example here, we have the article on financial crisis, and we're not linking to vague things like situations. We're not linking to things that everybody knows about, like value or 20th century. We're linking to things that are really relevant to this story, like banking panics, recessions, stock market crashes. So as I said before, Wikipedia contains millions of examples of what is a relevant topic to link to and what is not, given the context of the article. And we want to learn from that. So I've made a machine learning approach, which first we just did that thing I showed earlier of just trying to separate out the chaff from our potential concepts just by looking at the prior probabilities. So things like 6 and half and the are going to have very low probabilities, so we just ignore them. But we gather these other concepts like central banks, Bank of England, interest rates, and also overlap doesn't matter. So we're picking up central banks and also banks. And we run the disambiguation classifier, which I described earlier, with those two features, commonness and relatedness, to try and identify, to get a one-to-one mapping between each of these different n-grams and the relevant concept. And the next step is we need to learn which ones to throw away and which ones to keep. So in training, we would do this to a Wikipedia article. We'd take the text, detect all of the possible concepts it could link to, and then our good examples are the ones that were linked to, and the bad examples are the ones that weren't. And also, because we're dealing with not just n-grams, but also text, we can gather features that are not just like where it's found in the document or how long it is or things like that. We can deal with things like how much it relates to the central thread of the document or how general and specific it is. Like the intuition being that we wouldn't want to link to general topics like bank because you'll know about them, but we would want to link to central banks because you might not know about them. You need to click on them and find out. So we do that over training on Wikipedia articles, but if we go and do the same thing in testing on things that are not in Wikipedia, then we can use the same classifier that was trained to make the decisions and actually pick out the ones that are useful, the ones that are interesting. And that is the actual accurate figure for this thing. So what that means is we took a bunch of Wikipedia articles, completely removed all of the links in them, and then tried to put them back in automatically. And only 26% of the links, the new links, were not found in the old document, and only 26% of the old links were not found in the new document, which is pretty good, really, because this is a completely subjective task. You and I would argue about what should and should not be linked in a Wikipedia article. We also tested it on news documents that are nothing to do with Wikipedia and had human evaluators. We used Mechanical Turk to get people to look carefully at every single link and tell us whether it was good or not, and also the document as a whole, tell us which links are missing. And we got the same sort of figures. Okay, so demo this. So here's a null about San Francisco, and I am going to try and Wicify it. Bear in mind this is just running on my little research machine back at home, so it's not going to be very fast. And also, for some reason, it messes up some of your scripts. But here we have, it's linked to San Francisco and Alcatraz Island, San Francisco Bay Area, San Francisco Peninsula, everything that's about San Francisco, and also its history, like .com boom and counterculture and things. Notice it hasn't linked to everything that it could possibly have identified. For instance, it's decided that, where is it? It's decided that Victorian is not relevant here. It's not a central part of the story. Whereas here we have another web page to Wiccaify. And we can see it has actually decided that the Victorian area and things like that are worth linking to, because someone reading this story would be interested in investigating this topic. Okay. One limitation of this whole thing is it's been trained on Wikipedia articles, so it expects to be making links to something that's like Wikipedia. Whoops. Let me just, here's a Google blog, and I can try and Wikify this, but this is a little bit different. It doesn't work quite so well because a lot of the features are about having a central thread, and this document's a bit short, maybe doesn't have so much of a central thread. So it's only been able to pick up Google and human rights here. But the whole thing is a machine-learned approach, so we could just train it on what we want it to pick up, or we could just tell it to be a little bit less exact about what it picks up. So here we have a lot more stuff like bloggers and free speech and privacy and things like that. Okay, so to summarize with that last bit, we can add explanatory links to any document. So we could do this to news stories, blogs, educational materials, nulls, possibly. And also, we could assist the creation of new Wikipedia articles. Like, you could imagine you create a new Wikipedia article, maybe there's a button that says just Wikify this, and then after that's done, I'll go through and only change the ones that are wrong. That would be cool. But that's, I should say, this is the work that won the award. It doesn't quite seem worth it at this stage because all we're doing is adding a few links to pages. What's the big deal there? But this has some interesting implications. What we're really doing is we're cross-referencing any document with the largest knowledge base in the world. So we can pick up the concepts that are in these documents. So for example, I ran it on the paper that was about this, and here's a sample of the concepts that it was picking up. So before we just had some words, we didn't know what they mean, but now we have a bunch of concepts that this document is actually about. And we're doing things like we're resolving ambiguity. We know exactly what type of ontology I was talking about. It's resolving polysemy, so it doesn't matter if the document was talking about data mining or knowledge discovery or KDD, it would show this same thing. And also, it's not a bag anymore, it's actually a graph. We know how these concepts relate to each other, we could cluster them. And also, as I said before, there's a lot of research going on in turning Wikipedia into an ontology. So if we tap into that, we could start reasoning about this stuff as well. We could tell that Hamilton is a city in New Zealand and it's the home of the University of Waikato. So we can improve how documents are represented. I'm going to be trying this sort of stuff for information retrieval, obviously, searching, but also exploratory search, making suggestions about what people can investigate. Luckily, some other people are going to be using it for other things as well. So Aliona, my colleague from university, is currently working at Google in New York. And she's working on topic indexing, which means finding out, here's a document, basically trying to tag it, what are the most important things that you could file this under or organize it. And so Wiccafication is a sort of just a starting point for this problem, and the relatedness stuff provides some interesting features for the problem. Another thing is document clustering. So another colleague of mine, Anna from university, she's currently doing an internship in EML, which is a company in Heidelberg in Germany. She's using it for document clustering. So the idea is we're representing documents by the concepts that are within them, and we can tell, not the normal way of just text overlap to tell whether they should be grouped together or not, but we can compare the concepts in them. We could have a blog article about Google and a blog article about Yahoo that even if they didn't mention anything in common with each other, we could group them together. And I've just came back from a very short internship at the same company in Heidelberg, where I was working with Vivi Nastasi on multi-document summarization. So we have a query and we have a bunch of documents that we know are relevant. We want to summarize those documents as succinctly as possible in relation to the query. And so this stuff is useful there as well. And that's basically it. That's the end of my talk. Here are some references of different things if you want to read more. So the top one is a description of, it's a comparison of Wikipedia and other potential knowledge bases, specifically a thesaurus. The second one is all about Koru and its evaluation. Third one is about the semantic relatedness measure. And the last one is what I just presented about Wiccafication and detecting the topics in text. And there's some web pages for demos as well. Okay. So yeah, feel free to ask any questions if you want, or.
Have you done any work characterizing the nature of relationships? So you've been finding semantic relationships.
Yeah.
But there's different kinds of semantic relationships.
Yeah, so this is the problem of turning Wikipedia into a structured ontology. I haven't been doing that research, but it's definitely something that's getting addressed. There's a lot of people looking at it. So pulling out is a and not as a relations from the category structure, or using info boxes to tell is this location within this other location, or things like that. Yep.
Have you got any contact with the Wikimedia Foundation?
Not yet. I'd like to suggest this, using this stuff to suggest new links or to find missing links would be cool, but haven't started that yet.
By the way, can you repeat questions because we're videotaping and broadcasting this as well?
Sorry. Yes. Okay. Okay.
Okay, well, thank you very much.
Thank you.